Hey guys, today in the workshop we've got a automatic garage door opener to have a look at. It belongs to my son. It's not doing anything. I don't know much about these things, but let's take it apart and see if we can fix it. So it's Chris from the Ultimate Recycler. Sorry if I sound a little croaky. I've had a head cold, but that's not going to stop me working in the shed today. Let's have a look at this, pull it apart, see if we can work out what's going on. I think it's going to be a complicated circuitry because it's got codes and everything. But because it's not doing anything, it might be a simple fault. Let's have a look. I find the best faults are faults where absolutely zero happens. It could be just as simple as a power supply issue. There might be a poor connection. They're certainly easier to diagnose than an intermittent fault. So let's first plug it in and just see what actually does happen. Well, I assume nothing will, but we'll try it. It has got a light in it as well. I don't have a remote for it, but Steve told me that it wouldn't work on the switches here or the remote. So we'll plug it in and see if we get any action at all. Okay, let's power it up. I heard a little, oh, it's beeping. So at least we know we have power there, but it's not doing anything. Now it drives from a spline at the back here, which I think would have gone on some sort of sprocket, and I think they drive by a chain. I didn't take it off, so I don't know. We've got a green flashing light in here. Operate. Well, the light works. I would have thought it might have supposed to have two lights, but we don't have any action from the motor. So let's pull the cover off and have a look inside. We'll turn the power off first. Okay, we'll just put an old towel on the bench so that we don't scratch anything. And there's 4 screws. Looks like the top cover will come off. Now we have a bit of broken plastic there. Wonder if this has been apart before. I have 2 screws in the end here as well, but that might be just for the light cover. Probably easy access to replace the light bulb, I suggest. Okay, there we have the main board for it. It's only one, oh, it's the light both sides. So one side isn't working, it might have just blown a globe. We can easily check that with the meter. Maybe there's a fuse gone for the motor. Be nice if it was something simple. This little wire is an antenna, I guess, for the remote control. All right, here we go. The main body of it comes apart. And we have the electric motor and a gearbox. We have a little relay control board here and a big toroidal transformer. Now, it's not as complicated as I thought it would be. And this is our control board. Well, we know we're getting power into the unit because the light came on. And this board here, we have mains coming in. We have a capacitor and an inductor or a coil, probably just to stop interference. We have the live mains going into the transformer. And that's either a relay or another capacitor. So not much on that board to actually go wrong. And because power comes into this board first, goes out to the transformer and then back to the circuit board, we know that's going to be all okay because we have lights and the light power is off the main board. So that's going to be fine. The transformer is going to be fine. The motor is obviously not working, but I'd say it's more likely to be a power issue to it. I don't think the motor itself would be no good. Okay, so I think our fault is going to be on this board here. Let's get the meter and just check that light globe for a start. And we've got a fuse in there to check. Okay, I've just got the meter here on buzz, so you should be able to hear that. We can tell that that light globe's okay, and this one wasn't working, but it still has continuity. Interesting. There's maybe one light globe come on at a certain part of its operation. Let's just swap the globes and see what happens. Okay, let's just power it up. We've got some beeps, we've got some LEDs flashing. I wonder if there's a fault code from how they flash. I might have to Google that. Now, how did we turn it on to get the light to work? Let's have a look at this control panel. I think we pressed operate, which was this one here. Oh, there we go. Both. Oh, okay. Interesting. Maybe it just wasn't connecting properly. It was a bit loose in the bracket. Anyway, both lights are working. Ah, interesting. Something's going on there, isn't it? Because it's quite firm in the bracket. Let's see if we have voltage. Well, we know we have this side because the light's going 21 volts DC. Ah, we have 21 volts. So it must be a dodgy globe, but then we swapped globes. It might have a little bit of corrosion around the inside of the connection. There we go. I think that's what it is. So I might just put a little bit of sandpaper around them and just clean up the connections. That's all it was. All right, so that doesn't fix our door opening, but it does fix our lights. Now, I don't know how to actually get it to operate to open the door. Our operate button should be a manual override of all the controls, I would have thought. Okay, what I might do now is turn it off. I'll make sure I short out the capacitor so there's no voltage in there, and I'll take that board out. It's only 4 screws. We'll just have a really good look at the board to see if we can see any obvious faults. So now I've got the board off it and I can't see any obvious faults. I did just check the fuse and the fuse is fine. So I'm not sure where to go from here, but it all looks pretty clean. And there's no bulging of the capacitors. There could be a bad solder joint maybe, but I'm pretty sure the problem is on this board. I've just fired the rest of it up. I've turned it on, and the input to the circuit board here comes straight from that toroidal transformer, and I've got 25 volts AC, and where it plugs into the board it actually says 24 volts AC in, so that's fine. So our voltage in is no worries. I guess I could plug it back in and check the motor output because the motor's 24 volts DC. But then if something's wrong on the board and it's not actually applying voltage to the motor, I won't get a reading there. I guess I could try power to the motor from a power supply to see if the motor works. But as for diagnosing a problem on this board, look, I don't know. It's not something I understand. I don't want to start pushing the control buttons because I'm going to muck up the programming. I can't see any faults. I might take it into the little room under my microscope and just have a look at all the solder joints. But it's a double-sided printed circuit board, so there's lots of tracks on this side and there's also tracks on the back, so it's a bit hard to work out the actual circuit, but physically everything looks okay. Okay, I've got the unit in on my bench. I've got my power supply here. I think you can just see this. It's set for 24 volts, and this is the power lead into the motor. So we can see, and it's 24 volts DC. So we can see if the motor fires up. Well, there we go. That sounds pretty good. It's drawing, what was it drawing? About 1.2 amps. I would assume I would feel that that's good. So that means that our power going into the board is good. And if the board can provide the right power for the motor's good. So the problem has to be on the board somewhere. But where? Now, I've had a really good look over all the solder joints, all the components. Nothing's obviously burnt out. Everything looks fine. I've tested a few things that I can test. There's a lot of very small surface mount parts in here that I'm not going to have a hope of doing anything with. So all I've done, I don't expect to have success with this, but all I've done while the board's out was I've resoldered quite a lot of the points that there's a little bit of corrosion over this side, but nothing, it probably wipes off. But I've resoldered all the major solder points, particularly on things like the MOSFETs or triacs or whatever they are, and that's a bridge rectifier that tested okay. But anything that's likely to get hot, anything that has a heat sink, I have made sure I've resoldered all the joints because heat can certainly cause a solder joint to crack. But other than that, I can't really do much more, so I'll put it back in. We'll just see if it works, but I don't think so. I'm not going to hold out hope for it. It's likely that perhaps it's something to do with the settings, because this wiring ribbon here that comes off this big connector and goes to the top of the motor would have a lot of sensors so that the door knows when to stop and all that sort of stuff. So it might be a problem in a sensor actually in the rest of the machine somewhere. But I've done all I can here. I'm going to put it back together and see what happens. I'll plug that back on, turn it on, and operate. That's actually promising. Our light's gone out again. That's there. I have to clean those connections. Let's turn that off. Hopefully it's not drilling a hole through my towel. No, it's actually recessed, so that's fine. I think we may have fixed it. It may have been a bad solder joint. We do have to get these lights sorted out. Operate again. Oh, well, there you go. Okay, I'm going to put this back together now. I think I've fixed it. It must have been a bad solder joint because it seems to be working fine now. Although one globe has blown, I might have just been vibrating them around too much. But when I power it up and we push operate, it seems to work beautifully. So I'll put the rest back together here now. I'll give it back to Steve. He'll have to get another globe for it. But I'm pretty sure it's fixed, and I'm pretty sure it was a dodgy solder joint. So even though I don't exactly know which one, I fixed it. So I'm pretty pleased to get this fixed today. It's something off my bench, it's something out of my shed, and it saves Steve going off to buy a new one, and we keep this one out of the waste stream. It just goes to show you don't need to be an electronics technician. I didn't understand most of that board, but if you know a few basics and you know how to be safe and test a few things, and as I said, quite often bad solder joints, the lead-free solder they use these days just does not last. So it's responsible for a lot of stuff going to landfill or going into the waste stream prematurely. This took me less than an hour. I'm not sure how much these things are to buy new, but at least we've saved that cost. This one should go back into service now. Thanks for watching. Catch you next video. Bye for now.